Today's topic is oscillations. Oscillations of a liquid in U2. Oscillations of a liquid in U2. Oscillations of a liquid in U2. It means basically when fluid is contained in a U2, but that U2 should be of a uniform cross-sectional area. That means the tube which you are taking for experiment, it should have uniform area of cross-section. That should be in the mind. ये condition है हमारी, ठीक है. That means whenever we are writing this, so we will consider a U2 having uniform area of cross section, and the tube is filled with the liquid up to the height of h. Mean to say, for example, up to the height h. These are the positions. Suppose if I say this is B position and this is C position. So liquid is kept up to the height of h. This is the mean to say. When you are compressing the liquid from the C side, for example, when you are compressing it from the C side through y distance, this side liquid will also go up. Try to understand. When we are compressing the liquid at this side up to the distance v, that y distance. For example, mark is a d. The liquid will also displace to the upside up to distance y. So this is the new position for this. New position is it. That means we are compressing the liquid at this level. Initially, again मैं आपको बोलता हूँ समझो ध्यान से. Initially the tube is having a uniform area of cross section and the liquid was filled up to the height L, both sides. That was the initial condition. That is the initial equilibrium condition. The liquid is pressed from the C side through a distance y, and then liquid will move also up this side also through distance y. Now, when we leave the liquid, then the liquid will oscillate. We will prove it how it is oscillating. So we will consider that is the length of the liquid. That means mass. Here M stands for mass per unit length. Per unit length. It means the mass of the liquid in the unit length. In the unit length. Try to understand these things. So when we are compressing it, so what is the restoring force? What is restoring force now? See, this is the mass per unit length. See, you have gone through distance y and you have gone up also to distance y. So net mass will be m into 2y. And g. This is the weight of the liquid. And minus sign shows that the restoring force. It is restoring force. Right? It is clear for you. Now, the initial mass of liquid is what basically? Initially, the mass of liquid was, total mass of liquid was m into 2h. Why m into h? Because liquid was filled to the up to the height h here. As this side, as this side. The total mass of liquid, that is m into 2h, because 2h is the whole length up to which the liquid is filled. Now when we apply this, the acceleration is equal to restoring force divided by mass of the liquid. So this becomes minus m into 2y g divided by m into 2h. Here you will get minus y by h into g. Y by h into g. Or we can say, if we can write g by h, that is the g by h. You know why? Because y यहाँ पे क्या है? Variation है. G constant value, h constant. Initially because liquid was filled up to the height of h. So h is a constant term, g is a constant acceleration. So we can write this way. So what we have learned from here, that acceleration is directly proportional to minus y. It shows minus sign shows that acceleration towards the mean position, and y shows the displacement. So to prove an SHM, we need to prove that acceleration is directly proportional to the negative displacement. So here we have proved that acceleration is directly proportional to the negative displacement. So that means the liquid filled in a U tube having oscillation. Having an oscillation. बहुत simple सा fund है. Again I will tell you that initially liquid was filled up to the height of h, both side height of h. When we have considered mass per unit length, that means total mass in the liquid in the tube is m into 2h. So when we displace the liquid through y here, the liquid will go by this side also. Try to the total mass of the liquid through distance y is m into 2y, and g is the acceleration due to gravity. This is the restoring force which will be developed in the liquid when we are compressing the liquid through distance y. Now to know the acceleration F by m, F means restoring force and m means total mass of liquid in the tube, contained in the tube. We got this term, and we have proved that acceleration is directly proportional to the negative of the displacement. It means we have proved that liquid is having SHM when it is compressed through a certain distance in a tube having uniform area of cross-section. Keep in the mind, again we are repeating that having uniform area of cross-section. Here we also can write that is means time period for the liquid for the SHM. So what is the time period basically? The time period is 2 pi. That is displacement divided by acceleration. Displacement divided by acceleration.